And thanks Jackson and Alex for joining the DS Incubator. Today I wanted to talk a bit more about the cloud. It's going to be the previous last meetup. I'm trying to address the topic of moving data around, which is not so trivial. It's not rocket science, but it's not so trivial. And today I wanted to show one particular way of moving big data, in particular with, big, depending on what you call big, but relatively large data, with the GH command line application between your servers and GitHub. Because like with the traditional use of Git, where you put your stuff in Git commits, you can do only so much when it comes to sharing like big files. So that's what I wanted to kind of cover today. So it's a little geeky, maybe not for everyone, but I'm kind of excited about how I'm using that tool, and I wanted to share it with this audience today. So I'm gonna expand this here and I'm gonna get into it. So I already have a little droplet, a server on DigitalOcean. If you don't have an account, you can sign in for one, and then you get $100 credit. That is more than enough to practice what we are doing here in this series. So this demo droplet has this address that I'm going to be using to connect to it, this number IPv4, and so basically what we're going to do to connect to it is I'm going to pop up my own terminal and use the command line program SSH. I'm going to say I'm going to be the user root at, I'm going to paste the address of that droplet, and that will connect me to the droplet itself. But I've been trying to advertise the use not of the droplet straight, but instead of using containers inside your droplets. You don't have to, but I'm going to be using that. So what I'm going to be doing now, I'm not going to explain much because I have covered the use of Docker containers in a different series, so you're welcome to watch that one. But basically, like very briefly, I'm running a container from the Rockerverse project. I need an address where to connect to it. I need a password. I'm gonna be the root user there, and I'm just calling it GH so that I know the name of that container. I'm gonna remove the container once I don't use it anymore, and I'm gonna detach it from the terminal so that I have an interactive terminal right after I run this command. So for now, I'm just gonna copy that and paste it on here. So let's wrap this up. So I'm gonna clean this up with Control L. Where I am here is no longer my local computer. I'm here using the terminal to connect to that droplet. I am actually in that DigitalOcean droplet, and I'm about to create a container inside that by pasting the code that I showed you a moment ago. So that's that. So if I do now docker ps, I should see that GH container running. So that's it, it's working. And I want to now access that container through my web browser. I'm going to create actually let me first go to some browser, and now here open a new window in that browser. How can I, here. I wanted to get an incognito window there, and let's go back to my notes, which are going to be useful for, if I find them, for the rest of the meetup. So here are my notes, and here is the web browser. The next thing I'm going to do is to connect to that container that is running using the address that we copied from the server from DigitalOcean, and then the address that we gave here, that 8787, that one there. So I'm going to use that to connect to that. That should give me an access to log into RStudio. RStudio is the username for this container, and the password is the one I chose. I chose 123. So I'm going to connect to that now. So let's move this here to the right. Well, this gets there. Just one more step for setup, because I'm going to be using a Git at some point. So I'm going to configure basically who I am. I'm going to tell Git who I am, my email and username. This is something that you always do every time you kind of create, you start a new fresh computer. Oh, RStudio is disconnected. Why? Let's see.
That was me. I just wanted to see if I could access
Ah,
the port
nice,
from
nice.
that thing, and I could, and it booted you off.
Good, that's fun. Lovely. So you have my password, my super secret password, so you can. So actually, I'm now using my earphones, so I'm not recording that. So Jackson has just connected to the droplet, which kind of kicked me out of my own DS incubator. But thanks, Jackson. We proved that it works.
I was curious if it was secure, and I was going to ask, but then I realized I could just check.
Yeah, I mean that's a public address, and you can connect from anywhere. Actually, that's also why I'm using an incognito browser. So right now, like DigitalOcean doesn't know who I am really, or no, and I'm just incognito, right? So yeah, if I could connect through this web browser, anyone in the world could. By the time I'm gonna share this video, though, the droplet will have been gone, so no one will be able to connect. But yeah, you can do it now, Jackson, for sure. So now if I say git config config user name, I should get my own name. So this is nothing related to moving data, it's just set up. So sorry, it's a little boring, but we have to do that. Let me expand this a little bit and get my notes back in here. So this, I'm gonna move here to the left and expand. So, and now is the interesting part. So in this meetup, basically what I'm doing is advertising the GH command line interface, which I find super useful. It was Jackson actually the one who first introduced it to me, and since then I've been using it quite a lot. So if you click on that URL, it will take you to the website of it, and then if you follow the links to get installation instructions for whatever is your system, you'll be installing it fairly easily. These days it's very advanced compared to like a couple of years ago when Jackson and I started using it. So everything runs super smoothly, including the installation, and this is the code I need to copy to run or to install that tool in Linux, which is the system that is running inside this container, right? So I'm gonna paste that code. That all just works, and in a moment I need to press enter again because there is one more line which actually runs the install, and that's all I need to do to begin with. Let's move my notes here again. Where are we? Notes here. So now we are gonna first just prove that we can use just Git as usual. But in this case, talking to Git and GitHub using the GH tool, and we're going to be using it to basically share some data between the droplet and the container that I'm running here inside this droplet and GitHub. So let's do just that. So first I need to actually get some data. So if you want to get data from the world, what you could do is, as usual, like a Git clone with the URL that points to the repository that you want to clone. So that's not rocket science. That's if you use Git, that's the usual thing. But today I'm gonna be using the GH tool just because I want to advertise it. So it's a little simpler. You just say GH and the subcommand repo clone. And here, instead of having to pass the URL, which is a little wacky, it's a little complex. I mean, it's not hard to memorize. Eventually you learn it, but still a lot of typing. So simply you just give the name of the repo with the owner before. So organization or owner / repo name, as it makes sense, and there you go. Get started. So the reason this fails is actually because I was kind of probably running ahead of myself. Yeah, there it is. So we need to first authenticate, and this is actually a really nice way to set up any fresh environment that you have through the GH command line application. Usually, we need to create an SSH key to start talking to GitHub as an authenticated user, right? So that's what we're gonna be doing right now. So one thing that I really like from the GH tool is that it's very intuitive. So if you know nothing about it, the first thing you would do probably is to type GH and then enter, and what you get is already some help. For example, the very first thing that you see is how to authenticate with GH and then the command auth. So let's do just that. GH auth, and that again won't authenticate. That again won't just do it. We still need to say login, but it's nice that instead of getting errors, we get pointers to what we actually should do. So I'm going to do up arrow here and login. And now we're going to be doing in a pretty fluid way something that is sometimes very awkward, which is the idea of creating an SSH key and passing it to GitHub so that basically GitHub knows who you are. So there's two flavors of GitHub. GitHub.com is the one we always use here at 2 Degrees. There is also an enterprise version, which is not the one I want right now. And there is a couple of protocols you can use to connect. I'm going to be using the SSH, which is the one that we have been using at 2 Degrees. And now I'm going to say yes to actually create an SSH, because in this little container, which is totally fresh, there is no SSH key yet. So I'm going to choose not to give a passphrase, just to make the demo simpler. You may choose to do it. And I'm not going to change the title for the SSH key. The SSH key has a name, the GitHub CLI is okay for me. And now I have to say how I want to authenticate. The login with a web browser sounds good with me. So I'm going to copy this thing. That's what the prompt says. So copy this number. Maybe I'm going to make this a little bigger for your eyes. And then press enter as the prompt say. And now I'm told to go to this URL, right? So I'm going to click there. This window opens, and now is the normal login to GitHub. So basically what we are doing, just to kind of reflect, we have to tell GitHub who we are, and from that new little computer that is running inside that container. So once we do that, that container will be authenticated. So we will be acting as someone that GitHub knows about. So here I have to just say my username, which is this one, or email, any of the two is fine. My password here. And now, because we are very safe here, we want to use as many ways to authenticate as possible. So I have an app in my phone, and I have to type the number 57 on my app and approve. I'm doing that right now off the screen. And here's where I have to paste the number that I copied from the terminal. I'm going to show you that one more time in case you forgot. So just the sensible things to do. Where is my terminal? It has to be here, right? Yeah, here. So this number here is the one that I pasted. So that's it. So now the SSH key has been created. We get the name of it, and I'm logged in as myself. So that's really good. So that in itself is fairly useful many times when you create a new, say that you want to clean up your computer, and you have to start from scratch. How to create a SSH key. You can do it now with GH. So now we are gonna get actually finally now we have everything set up to the two things that I wanted to show. So how to use GH to actually get data from GitHub. As normally you can do it, as I said before, with git clone. And now we are gonna do it with GH repo clone. The first time you use a SSH key, you have to say that basically just say yes to that. And here I have just cloned a repo. So if I do an ls here, you see that there is this repo called ds.cloud, which is the one that I'm using to host the lessons of this meetup. So I'm gonna cd into that ds cloud just to show you the contents. It's just a repo, there it is. And in here, I'm gonna create some data. That is what I'm gonna pretend here that that's what I want to share. So I'm gonna create the data, the directory first, make dir data, and then I'm gonna create some files there, data a CSV and maybe data b CSV. So that will do. So if I do an ls in data, you see that the data is there. So the first thing you could do. If this is small data, there is no problem. You just do a git add data, git commit, say new data, and then you just push. So that data will boom go to GitHub, and you can prove that. We can go to that URL. We can do github.com 2 degrees investing ds.cloud. And look at it and admire it on GitHub. There is our data with its two files. But the interesting bit here, and probably the core of this meetup, is that that data could be really large, and there's only so much data you can push inside a commit. So for that, we're going to be using what's called GitHub releases, which is a way supported by GitHub. So here are some notes that it says, GitHub itself says that if you need to distribute large files, you can create releases and then attach the files as binaries to those releases, and it can be as big as 2 gigabytes each, and there is no limit as for how many files you attach. So you can have any number of files, 2 gigabytes each. So that's great. So the first thing we're going to do now here is actually create a release, and GH allows us to do that. Let's call that release V1, just for simplicity. So GH release create. Of course, that is associated to a GitHub repo, so I have to have here some repo. I have one repo, for example, in my own account that is called assets, and I use it exclusively for that. It looks like I committed. Okay, so here is a typo, create, that I need to fix. So if I create that release, I'm gonna accept everything here, the name of the release. I'm gonna leave blank the notes. I'm gonna say this is not a pre-release, this is an actual release, and I'm gonna click here on publish release, and that's it. So that's the very first step. So if you go to the repo now, you should see that in the releases section, so you can click here on the name of the repo, go back to the main page, and now in releases there is one release. It should be pretty much empty. There is 2 assets that belong to the code, basically the files that the repo contains itself. But the interesting thing is that in a moment we're going to attach here a file that contains that data folder that we just created a moment ago. So the first thing I would like to do though is to compress that folder, because we cannot attach the folder as it is. We need to kind of compress it into a single file. So for that we're going to be using tar. There's a couple of ways in which you can create compressed files, but I'm going to be using tar. So basically tar is a command line application, and you say C for create, the Z for compress as like a gzip, and F is to tell which file is the one that's going to host the archive, and then you just say which is the folder that contains all the files that you want to compress. So let's paste that here. So if I do an ls now, you see in red that there is this file is a compressed version of this other folder here. So now the code is pretty straightforward. Oops, sorry, so many windows. So what we're going to do is we're going to use GH and say release upload. We have to say which release, which is in this case V1, and which file. Is going to be the file data.tar.gz. So I'm going to run that. Oops, sorry, the bar at the end was unintentional. So I'm going to remove it and run again. It's thinking a little bit, and then it just sent it to GitHub. So I can look here on GitHub itself, refresh, and there it is, the file, right? So pretty straightforward, and this file is tiny, but it could be, again, up to 2 gigabytes per file. So Jackson, if you're still there, I acknowledge that it's 5 minutes to go. I have enough time to show how to actually do the reverse thing. So now how do we get a file from a release that is attached as an asset to release? So I'm going to push through that, and then maybe we can have a little chat about what we have just done. So let's go back to the notes. Awesome. So now the reverse, right? So we are now in the other situation where we are inside a droplet, or actually this also could be your local computer. But I found it useful when I was working with on the cloud, so that's why I'm sharing it here. So what we're gonna be doing now is, okay, let's pretend that we are at the home directory of this computer. I can do an ls and see that repo is there. It's the repo that contains the release, but I don't really need it, so I could even remove it. I could completely remove it, so an ls now shows nothing, and from here I can now basically get that file that is attached as an asset to the release that we created before. How we do that, it kind of makes sense. It's a little complex if you are not standing in the repo. Like now, for example, I'm just standing outside the repo that has that asset, but it's still not so hard anyway. So basically you say let's expand this to kind of walk you through the call. We're here. So you say GH, which is the tool that we are using now, and now it's release download. Again, we have to say which is the version that, the release to which the asset is attached to. And then we have to say the file. In this case, the file unfortunately is matched by pattern. So we say -p for the pattern, and you could give something that matches this file exclusively. So nothing better than the whole file name to me. And because we are not in the repo that has the asset, we have to explicitly say which is the repo, which is in this case 2 Degrees Investing ds.cloud. So let's do that. So let's copy that command. Go back to the terminal. And it did its trick. So if I do an ls, you should see that file there. And then the rest thing that we need to do now is probably just uncompress it if that's what we want. So with tar, what you do is you X for extract and the file that you want to extract. Actually, I noticed that in notes I forgot to say the file name, and that's it. So with ls, you would see now that the data folder is uncompressed, and if you ls into it, you see the files that you wanted to bring from GitHub into the terminal. So that's it. The two ways. So we got data from GitHub in two ways. First, with normal Git, assuming that the files were small enough, and second, we did it with GH, attaching, basically, using the GH tool that allows you to upload and download assets to GitHub releases. Let's go back here to Jackson's faces and Alex's face and see if there's anything here. Have you ever used this, Jackson, before? Releases and assets?
I've used releases and assets, but I've never used it in this way. I've never attached data or compressed data like that. That's pretty cool.
It's cool. I know, I became more aware of it through the piggyback package in R, which uses extensively that idea so basically you create a little, if you want to move data around and host it on GitHub, but the files are big, you can just use that idea. So you attach and detach and upload and download assets to GitHub releases. And then I noticed that the GH command line application was using it. So I found it really useful now because on the cloud I'm scraping a bunch of data. So I end up with these servers that are super overloaded with data, and I need to get it out of there. So I could bring it to my computer, but then it's not kind of backed up, and then the thing I would like to do once it's in my computer is to move it to GitHub. So I found that this way is kind of more direct. From the server, once it gets overloaded, I just compress create a compressed folder with all the data, move it to GitHub in one single repo that I call assets, and then delete the archive from the server, so I don't have to kind of grow the server that much. Which is kind of what I showed last time. We can expand the size of the server, but then you have to pay. So okay. So this way, this is free. You can attach as many assets as you want. There's no limit in the size, and 2 gigabytes per asset is pretty good for me. Yeah.
So you can have as many assets as you want, and there's just the 2 gig limit per asset.
Yeah, which is pretty surprising, no? That you could go crazy. But yeah, apparently, so far I haven't reached the limit, and I have more than 10 gigabytes associated to one single GitHub release.
Yeah, that's super cool. Yeah. It's cool because you can also do release notes and whatnot with it, so you can kind of if you're using that as a data, not a database, but as a data solution, you can have any changes that may need to be made.
Exactly. Yeah. Actually, the way I'm now distributing data in this project is. So I have code, of course, that scrapes some data, and then I create a compressed file with the data that I scrape, and that's inside the same repo. So it's kind of nice because, as you say, basically you have the code and the asset linked together. But I'm kind of using the system a little bit in that I have another repo exclusively for assets, so they are not associated to the code that generated those assets. Alex?
Yeah. A word of caution with that is anytime you're using anything related to Git for managing data, the double-edged sword there is the provenance chain. right? Because with Git, it's you say like, I release my data, then I release my next set of data, then I release my next set of data with all of the updates to it, right?
Mm-hmm.
And if you ever have to go back and edit an old set of data, for example, like you lost the rows or something like that, or you never should have internet in the first place, then that is a situation where that provenance chain will absolutely come back to bite you. So it's a definitely in that it is good. It shows like you do have this sense of showing progress over time, and in that sense you do show that you are building upon the old data sets. But if anything goes wrong with that, it becomes massively more difficult to actually resolve the problem, because then you're going around chasing down all of the issues that are not the actual problem. They're administrative and data management issues.
Yeah, good call. Thanks, Alex. Yeah, I mean, like, funny enough, I don't have a lot of experience with large data sets that are not a good fit for just Git commits. So this is like one exploration of that, but I'm pretty sure that this project will push my limits and teach me other tools that are more suitable for that. Are you aware of any? I mean, I know of some tools that are the kind of the Git analog for data. Like, are you now? What would be your tool to go, Alex? Do you have any particular recommendation for managing like data through time in the most efficient way?
Honestly, the best thing that I would do in something like that, if you have discrete time chunks, is I would manage them separately on a file server and use file paths to distinguish between them. Because then I would use file paths and like take an MD5 of a directory or something to show data integrity. Because if you can do that, like one of the things that is valuable about using Git is showing, yes, this is actually the data that I intended to be. Right? The Git is useful because it packages everything up, and the SHA-1 hash is the SHA-1 hash, and if it matches, then I have everything. But that does make it very difficult for managing large data sets, or if any individual file goes wrong or needs to be changed, then the entirety of the data set is compromised. So that is a problem we are actively dealing with as we're doing the Pacta migration. So I don't have final thoughts on that yet, of how we're going to manage all of this, but it is something that is worth considering.
Sure, yeah. All right, thanks a lot. I think it's gonna be so next meetup next week. I'm on vacation, so no meetup, and then the last one of the series is the one following that. So that's it, and then after that I'll be in Berlin, so maybe we can have a DS incubator in person for those who are around. Thanks everyone. Thanks for joining. See you next time.
Awesome. Thanks for your help.
Ciao, ciao.